Hello, we are talking with Moran Cerf. Hello, Moran.
Hi, how are you doing?
Hey, very well. Nice to see you here at the USI event. Your presentation from yesterday was great. And I want to ask you a couple of questions. So the first one will be, you mentioned about Human 2.0 and the event with your delay fly. So you said that people might have, for example, wings, but the brain needs to accept them. Do you know anything about the brain, how it's accepting it, and what language is it running on?
So the beauty of the brain, and that's kind of what we're learning right now, is that it's a machine that's multi-purpose processing system. Whatever you plug into it, if it speaks the same language of the brain learns how to control it. And we don't know the capacity. We can just keep plugging stuff to the brain. As long as the language interacts well, the API of the brain and the interface that it's using are the same, then the brain learns. So the example of the wings suggests that we know now how to build wings. We build airplanes all the time, so we know how to build things that actually have aerodynamics that fly. We even know how to take a mass of, 170 pounds and find the right wing that will fly it. But if I attach wings to you, you will feel it's like something that you control. People have like all kinds of like devices that they can fly with, but it doesn't feel like part of our body. What makes something part of our body is if it speaks to the brain. And if we take the wings and we teach them how to speak in the electrochemical signal of the brain, which is not too complex, we know how to make things speak the language of the brain. For a while, people thought that, okay, we can speak the language, but the brain is just going to not know how to talk to that, because it's going to be you bombarding the brain with new data that it won't know how to work with. What we learned in the last couple of years is that the brain actually does the rest. So if you just take the wings, make them speak the language of the brain, and plug them to the brain starts doing its amazing work in learning how to read the signal of the wings, and it's going to learn how to control them. The same way a baby learns to speak. When a baby is born, no one actually plugs the world into the baby's brain. We just give the brain information from the world, and babies somehow, through feedback, learn. They try things and they see what works, what doesn't work. They hear themselves bubble and they say, oh, I guess this is my voice, and they play with that. And within a few months, they learn how to speak and how to see and how to move. In the same way, it's going to take a few months, but if you plug a wing to the brain, and of course, it's hard to build ones and it's hard to plug it to the brain. But if you do that, the magic will happen from the brain itself. It will learn how to control them. And then you can actually have a human who learns how to flap his wings and, fly around without using Delta, American Airlines, or Air France.
Yeah, that would be ideal technology, I think. And speaking next, you also give an example with a monkey since 10 years ago, where the monkey started controlling an artificial arm. Can we in the future expect that people might control like a third arm or stuff like this? I think you already somehow answered on this one.
So one of the examples that I mentioned in the talk that kind of is interesting is an example that's been with us for 10 years, but I think people spoke about the wrong thing about it. People spoke about the technology, where I think the philosophy is much more interesting here. So the idea in the example from 10 years ago by a guy called Andy Schwartz at the University of Pittsburgh is one where he took a monkey, he tied the monkey's left arm to the back, and he put electrodes in the monkey's brain in the part that controls the arm, and he put a marshmallow in front of the monkey. So the marshmallow sits there, the monkey tries to reach for the marshmallow and grab it, but because his hand is tied, he can't move it. But he still thinks the same thought that would move the hand to get the marshmallow. What they did then, they also put a robotic arm that is activated by the thoughts of the monkey. So when the monkey tries to move his hand and reach for the marshmallow, he thinks about that, the thoughts get read by the robotic arm, and the robotic arm goes to the marshmallow, grabs it, and brings it to the monkey's mouth. So after a few trials, the monkey basically learns to control a prosthetic arm and feed itself just with his mind. And this is what got a lot of attention, and for 10 years we spoke enormously about the ability to actually read someone's mind and control devices outside. What I think is more interesting and isn't discussed is that when the experiment was over and they untied the monkey's arm, he could in theory just now go back to using his own arm to get the marshmallow. He didn't. He still used his mind to control the robotic arm and have the robotic arm go and grab the marshmallow, and he used his own arm to actually scratch his hand. So in a way, the monkey learned within a couple of days of practice to control a third arm. He now has his both biological arms and a third one, which means that our brain is so plastic that it's capable within a few hours to actually reallocate resources and actually get more tasks, more skills. And this is to be remarkable. This means that when we put the wings in the brain, it won't be like that we're going to lose some other things. We're just going to get more. The same way when you learn a language, you don't, for new languages, you don't like take out one. It's not like you have 3 languages in your brain, and if you learn a third one, you're going to lose one other language. You just have more room. And we don't know what the limit is, but we're not close to getting to it. So it seems that the more we learn things, we just have more knowledge. We don't say, okay, you learn this at the expense of that. And that's, I think, the magic. Like a third, a fourth arm, a second leg, a third leg, a tail, anything can be added without taking anything out.
Sounds very interesting, and I hope to see this in the future. You also made a clear separation between brain and conscious. If brain can be, let's say, modified and enhanced with new skills, conscious should be remain the same. Do you know anything about conscious and where it's located, or how we can let it untouched?
No, the answer is we don't, and I think that that's maybe nowhere. So the example I gave yesterday was one that came to me a few weeks ago when I was driving in Chicago in my car, and there was a huge traffic jam, and I was late, so I was upset. And then I talked to a friend on the phone, and he called me and he said, like, why are you so kind of agitated? And I said, because I'm stuck in traffic. And he said, you're not stuck in traffic, you are traffic. And I think what he tried to say is that like everyone thinks that traffic is there and they're the passenger, but it's only when everyone is there traffic emerges. And we think that consciousness may be the same idea, that there's no part of the brain that is consciousness, and this is the part that is you, and if you take this one out, then you're not yourself, and everything else is just like machinery. We think that all of the parts together, when they're there, consciousness emerges. And there's no such thing as like being conscious, as in just like when you can remember, and you can feel, and you can move, and you can think, and you can process information, and all of those, then you also are called a conscious being. So there's no one thing that we call consciousness. And that is a philosophical question rather than like a mechanical one, but it actually changes a little bit our behavior and how we study the brain, because it means that we can build one by taking all the components rather than trying to find this missing ingredient. It also means that there is something deterministic or at least less kind of arbitrary about our existence, and it also poses some question about theology. What does it mean to be human? What does it mean to kill a human, and so on?
I see. Yeah, really, really interesting, and it's interesting because it's part of everything. So, yeah.
Questions.
Yes. And now, coming back to the technical part, you also said that basically, especially for our readers, the brain is the best at machine learning, something that technology tries to do it today. Can we learn anything from how the brain approaches this process of learning?
So I think it's a great question, because I think that it changes really how the world is right now. So we used to build machines, codes that worked in a serial or maybe parallel processing, but were working their way. And they always looked at the brain, who was much better and much faster. Then we started having machines replicate the way the brain works. This is what machine learning is about. It's kind of trying to use the way the brain learns by examples rather than just by code and algorithms. And just with multiple examples, you just find the function that kind of maps them, and we call this machine learning. And then we built machine learning that are inspired by the brain, and they got so much better that now for most tasks that people have to compete, machines are actually beating us on those tasks. And chess and AlphaGo is examples, but also writing poetry and drawing pictures, they're now better than us. Like we can't tell apart like a human from a machine anymore on poetry writing. So and that's inspired by the brain. So now machines are better than the brain because they learned how the brain does that, and they do the same thing. And the interesting thing is that it actually has a comeback, because now we see how machines do things, and we now use this same idea to actually build better brains. So what I mean by that is that what my group and what I am looking into is basically the idea that now that we understand machine learning is so much better than us in thinking, say, maybe we shouldn't think at all. We should actually go back to feeling nature rather than thinking it, and then we're going to do what machine learning does, which is just respond to information that we're being blasted by and just let it solve problems. And that's what we're doing like right now with the sensory addition task, where we basically say, let's strip out any meaning from a problem and just give the brain a sound and have the brain say, is it beautiful or not? let's give the brain another sound. Is it beautiful or not? Let's give it a third one. And it's just like at some point the brain is going to start like hearing beauty in some sounds and less so in other sounds. And the brain wouldn't know what it's doing. It's just say, I like these ones more than I like this ones. And unbeknownst to it, oops, we have someone passing. What we're gonna learn is that the brain is actually really good in learning how to distinguish beautiful and not beautiful sounds, and in doing so, it actually solves complex problems. And that's what we're doing right now in neuroscience. We're trying to basically map problems that are really complex into feelings.
I see. Yeah, really interesting approach, and especially that can happen today. And one question regarding all this change, we require people to adopt them, and probably for most of them will not be something that they want, but for the people with health issue like Alzheimer, as you mentioned, or for people who want to feel better the stock exchange and they want to implant something in order to get some extra money, this will happen. How do you see this implementation and this transformation of people?
I mean, I think that there's a gap that is almost, I would say, religious, with people that say, this is me, you can't touch this, you can't replace anything in that. And this gap, once we overcome the barrier, gives us a huge leap. And we all suffer from that yet. So I think that we have to have a few pioneers do it first, and then we're gonna all chase them. So I'll give you like an example of that. So when I was a kid, every kid age 15 had braces. This was like a big thing in Israel, getting braces and making your teeth aligned. Everyone did that. Like there wasn't a kid in my class that didn't have braces. And now they got much better in knowing how to do it faster, and they have like transparent ones that look a little bit more aesthetically pleasing. But essentially technology didn't change much. We still take the teeth, their bones, and we just move them and twist them until they become aligned. That's kind of the technology. There's a new one that exists out there. And my dad, he once went to his dentist, and then he said, we can have, he's an older man, then said we have new technology right now that you might find interesting, because he has one tooth that's a little bit misaligned. And then he said, there's a technology that takes 2 hours to align your teeth. It's very fast and very efficient. So it's very easy. You go to sleep and general anesthesia, and then we break your teeth, and we put new ones, porcelain one instead. So and in 2 hours, we just take out all your teeth and we put new ones, and you wake up and you have aligned teeth. That's it. Are you kidding me? This is ridiculous. That's my teeth. You're not going to break my teeth and put new ones. That's like not going to be me. And that's the old-fashioned thinking that we all suffer from. We say no, this is my teeth. The new ones are going to be something else. But we know that all the evidence in the studies show that when you go through, say, heart transplant, when you put a new heart, you don't feel like it's someone else's heart. You just feel like it's your body. So my dad, if he took the surgery, he would just wake up thinking this is our teeth. He wouldn't feel it, but we still don't want it, because we have a sacred image of the view. It's like you can't replace my leg with a new one, it won't be me. This is my leg. And I think that little twist is what is the gap between us putting stuff in our brain and not. The fact that we feel somehow that the body is sacred.
I see. Yeah, really interesting. Okay. Thank you, Moran.
Thank you so much.
Thank you. Thank you very much.